The challenges in production engineering for automotive manufacturers are that more cars need to be produced in a shorter amount of time, while customer requirements are becoming more and more individualized. At the same time, manufacturing complexity is increasing, and there is a greater need for cost efficiency. The TIA portfolio with the TIA portal is the greatest lever for achieving these goals. The TIA portal provides the engineering basis for automotive standards. At the same time, the TIA portal is an engineering framework that we use to engineer and program the controller, visualization systems, drives, and safety components. There are many examples of how the automation portfolio and the TIA portal help automotive manufacturers. For instance, the integrated security concept for access and data security, as well as the integrated library concept in the TIA portal, make it easier to exchange data between the automakers and the line builders. Production engineering provides access to the digital enterprise. It establishes additional requirements for connecting to the Teamcenter data backbone. The situation today is that the data must be transferred manually from product design and production planning to separate software tools. We will change this in the future. Data from the mechanical, electrical, and automation systems will be automatically merged and made available. This can significantly reduce the time and effort required for engineering. We have the ability to use our virtual PLC SIM Advanced controller to perform virtual commissioning before production even begins, and also to simulate the equipment. This can increase overall quality and reduce susceptibility to errors. Siemens is the right partner for the automotive industry because we offer a complete portfolio, from product design to services, based on the Teamcenter data backbone. This gives customers full data consistency and maximum transparency.
I'm Becky Miller. I work at GE Aviation, and I'm a quality control engineer. Manufacturing is great because it lets you use your technical skills, your problem-solving skills, and your communication skills. And at the end of the day, I get to see a plane fly, and I know that I'm a part of that. Evendale, Ohio facility is GE Aviation headquarters. We do engine testing and development, we do manufacturing, we do assembly, we do sourcing, and we have our materials support team here as well as our corporate headquarters. We make very large parts at GE Aviation. Some of our parts are as large as 72 inches in diameter. And on a part that large, even an error as small as 5 thousandths, which is about the size of a human hair, can make a difference. I enjoy what I do every day. Every day I can go home and feel like I've accomplished something because there's always a new challenge for me to tackle. I think the false impression that people get about manufacturing is that they think that my job revolves strictly around machines or that I sit at my computer all day and analyze data. My job is actually very people-oriented. I work with groups of people every day to resolve problems. Even a small part can have a huge impact on the engine. This is a nut plate. It goes on our low-pressure turbine cases. This little part is so important that we decided we needed to do torque testing to make sure that this doesn't fail when our assemblers in North Carolina put the engine together. To get everyone to work together on a problem, typically I like to make sure everybody agrees that there is a problem. So an operator and the methods engineer, they have to work together, and if they both think that there's an error with our process, then it's a lot easier to go tackle that issue. I also perform product audits on our part. That is checking every characteristic of our material to make sure that our products are conforming when they go out the door every day.
Becky, this is a big part. What is this?
This is our low-pressure turbine case. This contains nozzle segments and assembly. The tolerance on the wall thickness is about 10 thousandths.
So a few human hairs.
Yes, that's all we get.
And you have to control the size of the wall to that precision.
it's a structures case, so we got to make sure that at the end of the day, everything will fit inside of it and nothing can escape it if something were to go wrong. The whole quality system is based more on our tight tolerances. It's not so much to do with the large features of the part, it's all the little ones that actually matter.
I'm seeing sort of a shiny metal surface here, but I know it doesn't begin that way. What does this part look like when it comes?
It actually comes in as a very large black forging. So there's a few more inches of material. It's this basic shape, but doesn't have all these features in it.
What steps happen to get it to look like this?
It starts in our turning processes. The turning basically makes the thickness of the case, and it makes all these distinct features on the inside. After all the turning is done, it then goes to our milling operations where we get our bolt holes put in, and then we have just a little bit of assembly on this part. Nozzle segments actually slide into these. And then that's important because the nozzle segments are supposed to be of a certain size, and we want to make sure that everything fits properly in assembly.
You are a quality engineer in the large parts area. Do you like that assignment, working on the big stuff?
I enjoy that our parts are so complicated because every day you see something different. We make these features on these machines every day, 2 to 3 parts a week, and you still see a challenge, at every step. And at the end of the day, I get to see a plane fly, and I know that I'm a part of that.